Hello everyone. Today we will discuss about the input impedance of the distributionless line. So this topic coming under unit 2 high frequency transmission lines. Alright. Here we are going to calculate the input impedance of the dissipationless line. For that we know about the input impedance. The input impedance is given by Zs is equal to Es divided by Is. Es is the sending end voltage and Is is the sending end current. We know the values of Es and Is from the previous equation. Simply we can substitute the values here. Er cos beta s plus j Ir r naught sin beta s. That is the value for Es, and Is value you can substitute as Ir cos beta s plus j Er by r naught into sin beta s. And in this equation we are going to simplify and we are going to find the values of Zs. And if we are going to look out the equation, numerator term consisting of cos beta s and also sin beta s, denominator is also having cos beta s and also sin beta s. From this we are going to take cos beta s as a common term in a numerator and also denominator. The first term of Er consisting of cos beta s, but the second term j Ir r naught is not having any cos beta s, so we have to multiply and divide by the value of cos beta s. So we can take cos beta as a common term both numerator and denominator, and we can cancel each other. At the denominator you can able to take the LCM value Ir r naught cos beta s plus j Er sin beta s divided by r naught. This whole divided by r naught comes into numerator, and this is the next step, r naught into Er plus j Ir r naught tan beta s, because here we have a sin and we have multiplied divided by the value of cos term we have taken out, and the sin by cos is equal to tan divided by I into r naught plus j Er r naught Er tan beta s. Okay, whole divided by r naught comes into multiplication term, and in this here we are going to take Ir as a common term. Right, here we are going to take Ir as a common term, and if this term doesn't have any Ir value, so we can divide by the value Er by Ir. Here this Ir is taken as a common term, j r naught tan beta s divided by Ir is taken as a common term, then we can write r naught plus j Er by r naught tan beta s, and r naught Ir gets cancelled, remaining we have E divided by Ir plus j r naught tan beta s divided by r naught plus j Er by Ir tan beta s. Okay, and this Er by Ir can be replaced by Zr value, right? So here we can write Zs is equal to r naught into Zr plus j r naught tan beta s divided by r naught plus j Zr tan beta s. And the input impedance is a complex in general, and it is periodic with variation of beta s. The period of being pi or s is equal to lambda by 2. What they are going to say is nothing but the input impedance is a complex value. Generally the input impedance is always a complex value. It is a periodic value, right? It's going to have a repeat the values for every values of beta s, or lambda is equal to 2s. Simply you can say s is equal to lambda by 2. And if we are going to write impedance in some other format, we can write in terms of Z is equal to Es by Is into Ir r naught Zr plus Zr divided by 2 into e to the power of j beta s plus k into e to the power of minus j beta s divided by Ir into Zr plus Z naught by 2 r naught into e to the power of j beta s minus k into e to the power of minus j beta s. This is another format. Already have derived one equation where the value consisting of Zs, and this is the another format. Just we are going to take this equation from the general solution of transmission line, but the previous equation is taken from physical significance. And here also you have to do the same simplification, right? Here also you have to take the same simplification. So here we have common term Ir Zr plus Zr as a common term. We can cancel in the numerator and also denominator. 2 gets cancelled, remaining we have r naught only, right? R naught into e to the power of j beta s plus k into e to the power of minus j beta s divided by e to the power of j beta s minus k into e to the power of minus j beta s. So this is the value we are having remaining. If we are going to cancel common terms, remaining we have these values. And here what we are going to write is something but the c to the power of j beta s can be written as in terms of modulus value and also angle value. E to the power of j beta s can be written as 1 into angle of beta s. Similarly this k will be written as in terms of modulus of k angle of pi, and e to the power of j beta s written as in terms of angle of minus beta s, right? At the diameter also you can write the same value 1 angle of beta s minus k, which which is modulus of k angle of pi minus beta s, and phi is the angle of reflection coefficient. And if you are going to divide by the numerator and denominator by angle of beta s, we can write zs equal to r naught into here we can cancel this beta s value, so 1 modulus of k phi minus beta s. Already we have phi minus beta s. If you are going to divide by the angle of beta s, means again it comes into minus 2 beta s, angle of phi minus 2 beta s. Here is 1 minus modulus of k angle of phi minus 2 beta s. And we can write the conditions value here. The input impedance will be maximum at the distance of phi is equal to 2 beta s, where phi minus 2 beta s is equal to 0. In this condition we have maximum impedance value, so we can write the value s is equal to pi divided by 2 beta. In general expression, s is equal to pi divided by 2 beta plus n lambda divided by 2, whereas you can write zs max is equal to r naught into 1 plus modulus of k divided by 1 minus modulus of k, which is written in terms of r naught into s, where s is the standing wave ratio. And the input impedance will be minimum, where the input impedance value will be minimum, where the condition is phi minus 2 beta s is equal to pi, and we can write s is equal to pi divided by 2 beta plus 2n minus 1 into lambda by 4, and otherwise you can simply write 2 beta s is equal to pi plus pi, and we can write the substitute the value here. Zs minimum is equal to r naught into 1 plus modulus of k angle of phi minus phi plus phi divided by 1 minus modulus of k angle of phi minus phi plus pi, and we can cancel the common value. Pi gets cancelled, remaining we are having minus pi and angle of minus pi. So 1 plus modulus of k angle of minus pi, 1 minus modulus of k angle of minus pi. So we can simply write this minus angle of minus pi value will be minus 1. So we can write in terms of r naught into 1 plus 1 minus modulus of k to 1 plus modulus of k, which is zs minimum is equal to r naught divided by s. This standing wave ratio for a DC passentless line. Thank you.